So now we're going to continue with this lesson 6.6 on solving radical equations. The other day we looked at how we solved a certain type of radical expressions, and I think we got pretty decent with it. We're going to continue on today with a couple of problems that are slightly tougher, but it's the same concept. So let's look at this example here. You notice how in this case I have a radical here with an x variable in it, but I also have a variable on the other side as well. And there's no way to get a radical on one side and a number, just a number on the other side. So this is a different kind of problem. We approach it the same way. We square both sides. Notice what happens when we do this. So on the right hand side, when we square this, it becomes nice and simple. The square root goes away. On the left hand side, when we square this, x plus 1 squared becomes x squared plus 2x plus 1. And notice now we end up with a polynomial equation, basically. We do get rid of the square root here by squaring this term, but now instead we end up with the x squared polynomial, but we know how to deal with that. When we get down to and simplify down into this form, we set everything equal to 0 here, and we can solve this kind of equation by either factoring, or if we can't factor, we can use the quadratic formula. In this particular case, it's quite straightforward to factor this. We find that our solution is either 7 or -2. Now, we need to check this. We have to go back and check each answer and be very careful to use the very original equation when you go back and check it. Do not use this second line here after the squaring. We go back and use the very, very original problem, plug 7 into the variable x, and we see that in this case x equals 7 is a solution. It checks out okay. Now when we plug in 2, we actually find that it doesn't work, that when we plug it in we can't come to this equation. -1 is not equal to 1, so x equals 2 is not a solution. We have a single solution, x equals 7, for this equation up here. So the key concept here is we still raise the left-hand side, right-hand side to a power of 2 to get rid of this radical here, the square root radical. But we need to check for extraneous solutions when raising both sides of the equation where there is a variable on both sides. Let's look at one other problem. It's slightly harder. You notice the thing about this problem is we have a square root radical on one side, we have a square root radical on the other side, and there's no way we can simplify this down to one single radical right away. So what we do is we simplify it to a point where we have a radical on one side, a radical isolated on the other side, and then we square both sides. In doing so, the right-hand side simplifies and we get rid of the square root radical. On the left-hand side, we need to be careful when we expand this out. Remember this concept here. When I have a plus b quantity squared, it's actually equal to a squared plus 2ab plus b squared. That's the expansion of a plus b squared. So if we apply it to this case here where this square root right here is our a term, you could see this. We have a, this green quantity squared, plus 2. We have 2 times ab, so 2 times a times b, b is 1, plus b squared, again b is 1, 1 quantity squared. So this expands here into this equation here, and let's go one more line down, and this term right here, when we square it, becomes x plus 2. So we achieve getting rid of the radical here, but we're still left with a square root here. That's kind of interesting. When we squared this term, it did not completely get rid of the square root. We still have it here. So now we need to iterate again. We want to isolate this portion right here, just like we had done earlier. So we subtract x from both sides, 2 from both sides, 1 from both sides. And now we get down to this. We need to now divide by 2, because again we want to isolate this piece all by itself. So now we've isolated it, and now we can square both sides. We square both sides and continue on. We notice we have a quadratic here. We get to our quadratic and we attempt to factor it. If we can't factor it, we use the quadratic formula, but we can factor it. And we can then find two solutions, two possible solutions. X is equal to 2, x is equal to -1. At this point, we need to check our answers again. So we check x is equal to 2, and again, we use the very, very original equation up at the top to plug 2 into. We run through the problem, and we find out that actually 2 is not a solution. We plug in -1, we plug it again into the very original problem, and we check this one out. We find that in this case it does check out. 2 is equal to 2, so we have one solution. X is equal to -1 is the single solution to this original equation. The key concept here is that in this case you notice that we had to square both sides of the equation twice. We did it up here, and in doing so up here we removed the right hand side radical, but we still had a remaining square root radical on the left hand side, so we had to do more work and we had to square both sides yet again. And when we did that second iteration, then we got to a point where the square root disappeared. We were able to simplify that down into a quadratic that we could then solve. So that's the lesson for today.